Hello everyone, welcome back. So we continue our lesson on NumPy. In this video, I'm going to show you how you can create NumPy arrays on the fly. Many times you want to have a set of numbers because you may want to test your algorithm and you want to create certain series of numbers, a bunch of numbers in a certain way. So NumPy can do that for you. And because of the properties of NumPy, you can do all kinds of new sets of numbers to mimic the data that you may be trying to test in your algorithm when you're creating new software. And you can create quite large sets of numbers using NumPy, shaped in a certain form. So here, I'm going to show you a couple of methods, right, to get you started. And as you continue your studies and your development in coding in Python, you will learn other methods. So for now, this is an introduction. The first method that I'm going to show you is called LineSpace. It's a method that's part of the NumPy class. So you instantiate a NumPy array, and you can create a set of numbers using LineSpace. So LineSpace is the name of the method, and the way I'm going to use it, I'm just going to use it straightforward. You can make a variable name for a NumPy object equal to these sets of lines of code that I'm about to show you. But here, I just want to demonstrate to you what LineSpace can do for you. So basically, the first example is I'm going to run the LineSpace method of the NumPy library, and I'm going to show you what the results will be. And LineSpace is going to create numbers, in this particular case, from 0 to 10, including 0. I'm going to create, what the next is going to tell me. I'm going to create 11 numbers between 0 and 10. Between 0 and 10. I'm going to create 11 numbers. And the way NumPy LineSpace works, it basically says, oh, how many numbers do you want? 11. And where do you want to start? 0. So 0 is at the starting point. And how far are you going to go? All the way to 10. So 10 is your ending point. So since I told it to do 11 points, you will expect that it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And those are 11 points because remember, we're going to count as 0 in this case. But the main point is I'm asking NumPy to build, to create a bunch of numbers. So here it goes. So it created an array, and as we were expecting, is 0, 1, 2, 3, 4, 5, I'm overwriting now, 6, 7, 8, 9, 10. So I have 11 numbers between 0 and 10. How about if I go back, how about if I say I want 22 numbers between 0 and 10? So that's going to look a little bit stranger because now I have to break it down in between. Well, let's see what it does. So yeah, it does. It includes the 0 and then evenly spaces 22 items, 22 numbers between 0 and including 0 and 10, evenly spaces 22 of those. So if I say I want to test my algorithm with 22 numbers and I want to go between 0 and 10, I will do this, right? How about if I say something more weird, between 0 and 100, and I only want 15 numbers. If I do that, I get between 0 and 100, and I evenly get numbers spaced evenly between 0 and 100. I get numbers spaced evenly. I get 15 of those, 15 numbers spaced evenly like that. Let's invent a couple more. In fact, let me do this. Let me create a new cell, and I'm just going to copy and paste this one here. And I'm going to change it for you a little bit. And I'm going to say, I don't want it between 0 and 100. I want it to be between 50 and 100, and I want to have, I don't know, I'm going to have 25 numbers. So if I do that and I run it, there you go. I got numbers between 50, sorry, I just changed it to 50, between 50 and 100, and they are evenly spaced. It does the mathematics to evenly space the numbers so that it gets in it 25 of those numbers. So now let's see something I said. I just want to make sure you follow me on this. An array, I'm going to create a variable, and then I'm going to make it equal to one of those np.linespace instantiation. So in here, I'm going to instantiate my array by giving it to an array, a name of an array, or I tell you what, let me call it my array, because you see it's new, it's my array. And I'm going to go, let's change this a little bit so you see that I'm being flexible, between 60 and 120. And I'm going to get 30 of those. See what it does. Let's run it. You don't see anything, but you see that it ran. So let's create a new cell, and I'm going to look at it. I can do print, or I can do just type it in like this. So I'm looking at it. So yes, just like I said, like I asked it to do, I get between 60 and 120, and I get evenly spaced my numbers in there. So what about if we test that? Well, it already says here is an array. So how about if I just specifically ask for the type of my array, just to prove to you that we got a NumPy array. They call it ND array. Okay, so this is how I created numbers, or an array of numbers in a NumPy instantiation using line space. I just use line space for you. Now let's do another method. We have seven and a half minutes into the call, into the video. That's good. Let's do another method, but this time, instead of having evenly spaced numbers between the first number and the last number, I'm going to do random numbers. But I'm going to say, just give me a random number between this and that. In the first example, I'm going to get random numbers, and I'm going to give it to a variable. So I'm going to use it, which is going to be an instantiation of a NumPy array. I'm going to use it a little bit later in the next video when I do some plots. So I'm going to say, I want to do random. Oops, I misspelled random here, didn't I? Random. Let's spell it correctly. And I want to have random numbers between 50 and 100. I want to have 20 of those. I want to have 20 numbers between 50 and 100. So I'm going to run that. I'm going to instantiate the NumPy array on a variable called new 1D array. I'm introducing a new concept. 1D is one-dimensional array. Why am I doing that? Because in the next, a few seconds later, I'm going to do 2D arrays. Okay, so you can do multiple dimension array. So here I'm going to do a 1D array. So here's my instantiation, and this time it looks like each number is an integer. That's fine, and the numbers fall between 50 and 100, but they're randomly selected. It's not like in the previous one. If I had said line space 50 to 120, you will see the first item in my array to be 50 and the last one to be 100. Here you don't. Here each number is selected randomly. All right. And just to prove it to you one more thing, if I do len on new 1D array, which is the one I just created, if I do this, I see the length, or how many numbers, how many items I have inside that data structure, and it says 20, right? I could have done the same for the other ones, but that's okay. You see the point, right? So I asked it to do 20 numbers, and indeed I got 20. And these are my 20 numbers that I got. They're random. They're random between 50 and 100. between 50 and 100. It doesn't mean that it has to include the 50 or the 100, as long as it's between 50 and 100. And as you can see, all the numbers here, all the numbers in there are between 50 and 100. All right. The other thing I can do with my my array is I can ask for the shape. And the shape is basically the dimensions. So I can see there are 20. There are 20. Just like I did for length, I can see the shape is 20. I do this because in my next example that I'm going to start right now, I'm going to do a two-dimensional array, and I'm going to create my two-dimensional array with two random lists. Okay, so which is very interesting because you see, I'm going to instantiate an NP array, right? And my instantiation is a method to instantiate it. You can see it's a method because it's between those two parentheses. But inside the parentheses, I'm creating two random arrays separated by a comma. And those random arrays are within a list. So it is a list of random NumPy. They're not NumPy arrays. Yeah, they are NumPy arrays. There are a list of NumPy arrays. So the first list, comma, the second list. There are two of them. Or array. Let me rephrase it one more time. This is a list. This is a list. And inside the list, I have items separated by a comma. I have two of them. Here's the comma. And items separated by the comma. And each of these items is a NumPy array. It just so happens too that the length of each is 20. So they have the same size, but they have different properties inside. The first one is going to be a random number between 50 and 100. And the second one is also going to be a random number, but this time I'm going to do it between 10 and 200. Let me look. Yeah, 10 and 200. So between 10 and 200. So they're going to look quite different, the first and the second of these NumPy arrays that are separated by a comma within the square brackets. And that is a list, and that list is passed on to my array method of NumPy to instantiate what I'm going to call now a two-dimensional array. So let's do that so you can see how it works. There, it instantiated the first one, and you can see I'm gonna focus on the first one. The first one is this square bracket here and that square bracket there. That's the first one. All right. Has numbers between 50 and 100, and you can see 79, 70, 79, 70, 50, 54, 98. They're all between 50 and 100. Then the second one is between these square brackets right here, and they're separated by that comma, right? The two lists or arrays actually are separated by a comma. And those are numbers between 10 and 200. So you have 178, 63, 29, etc. All of them are numbers randomly picked, randomly selected between 10 and 200. So I just created a two-dimensional array, NumPy array. So what happens if I look at the shape? If I look at the shape, it says it's 2 by 20. In this case, it's a little bit different than the one above. There wasn't much sense of asking for shape when it's one-dimensional. It made more sense to ask for the length for the one-dimensional. But here, because it's two-dimensional, I'm going to ask for the shape. The shape is basically the dimensions of my data structure, and that is 2 by 20. So it's two arrays, and each one has 20 numbers. That's it. In the next video, I'm going to come back and describe how I can plot these arrays. Okay, it's going to be exciting. And I'll talk to you in a few. Okay, bye-bye.